Experts monitoring an oil spill from a crippled oil tanker model the oil slick as a circular disc of radius r meters and thickness 5 centimeters, which remember is 0.05 meters. The tanker spills oil into the slick at a rate of 5 cubic centimeters per minute. So that is going to be dV dt, and this is making me think that perhaps we should stick with centimeters rather than converting to meters. If the thickness of the oil remains at 5 centimeters, find the rate of change in the radius of the slick in centimeters per minute, correct to the nearest centimeter, when the radius is 100 meters. So that, of course, would be 10,000 centimeters. Now, we're finding the rate of change in the radius, and of course that is dr dt. So I've identified the rate that we've been told, and this is the rate that we want to find. Now, our slick itself is like a cylinder. This is the radius, and we know that this is 5 if we work in centimeters. So I'm just going to go for r in centimeters and work for it all the way through in that way. So the volume would be the area of the cross-section, which is pi r squared, times 5. So that means the volume is 5 pi r squared. dV dr is then going to be 10 pi r. We want dr dt. Making a chain for that, that's dr dv times dV dt. Now, if dV dr is 10 pi r, dr dv is just 1 over 10 pi r. And then dV dt we were given was 5. So dr dt, just simplifying that, is going to be 1 over 2 pi r. Now we want dr dt given that r is equal to 10,000. So we just need to calculate that. So that is going to be 1 over 2 times pi times 10,000. And that gives me 0.000, forget how many zeros there were, 4 zeros, 16, and that would be centimeters per minute. And that is correct to 1, 2, 3, 4, 5, 6 decimal places.